right? See, cross product of vectors is another operation defined for vectors, right? We do something with vectors such that we get the result in a particular manner. That is what is cross product. Consider two vectors A and B with an angle theta between them. Okay. Can one of you remind me the formula for A dot B? When you know the vector magnitudes and the angle between them, how do you express A dot B?
AB cos theta.
AB cos theta, correct. You can write this as A multiplied with B cos theta, which is nothing but, see, B cos theta is the scalar component of B in the direction of A. We used to write it as B parallel. Okay. So you can treat this as A multiplied with B parallel. You can also consider this as B multiplied with A cos theta. And what is A cos theta? A cos theta is the scalar component of A in the direction of B, like this. You can call it A parallel, component of A parallel to B. So the dot product could be expressed as B multiplied with A parallel also. See, actually, multiplying two vectors makes no sense. Vectors are not like numbers that you multiply them. Okay, vector has a direction and multiplying direction makes no sense. Fine. So dot product and whatever we are going to discuss today, cross product, these are just some useful operations that we define for vectors. Okay, like where did we use the dot product? We used it in calculation of work, power. Okay, because if you define an operation this way, dot product, it will be useful in calculating that quantity. That's all. Okay. Similarly, they have defined another operation for vectors or between vectors called cross product. Okay. Now, dot product takes into consideration the magnitude of both the vectors and the angle between them. In fact, dot product is the product of magnitude of one of the vectors and the parallel component of second vector in the direction of first. So wherever there is a situation in which you need the product of two vectors in the same direction, you can use dot product. Okay. Like in work and power. And the result of dot product AB cos theta is a scalar value. It doesn't have direction. It's defined like that. Dot product is defined without a direction. Okay. Because maybe you will never need or you will never require it to have a direction. Like in work, we didn't need a direction. Work is a scalar quantity. Power also scalar quantity. We didn't need a direction. So maybe that's why they didn't define a direction for dot product. Okay. So we can define another way of multiplying two vectors, and that is what we call cross product. Cross product is also called the vector product of vectors. Why? Because the result is a vector. Fine. We denote cross product like this. You are supposed to read this as A cross B. Never say A into B or anything else. Okay. Or A multiplied with, you can't simply say multiplication also between two vectors because there are two different ways of multiplying vectors. So you must read it as A cross B. Now A cross B will be a vector quantity, as I said. And if it's a vector, then it should have a magnitude and a direction. Okay. Let's first consider the magnitude part, magnitude of A cross B. Now, dot product is the product of magnitude of one vector and the parallel component of second vector in the direction of first. When it comes to cross product, we take the perpendicular component. Okay, let us denote the vectors in different colors first. Right. So the magnitude of A cross B becomes, you can take A's magnitude as it is, multiply it with the component of B perpendicular to A. Let's visualize that. We need component of B perpendicular to A. Imagine the direction perpendicular to A first. It is this direction. Now take B's component in that direction. We have to take its projection onto that direction. It will be like this. This is B perpendicular. Okay. Component of B perpendicular to A. It would have been better to draw it in yellow itself. Fine. Now see, the vector B makes an angle theta with the vector A. Then B's component parallel to A is B cos theta. Can any of you tell me what will be the magnitude of B perpendicular?
There will be same as B only.
What are you saying? Rishi, how can that B vector and this B perpendicular vector be the same? Can't you see that it is shorter? It is definitely shorter. It's like a component of B in a direction or along a direction with which it makes an angle 90 minus theta. And how much will that component be? Anyone?
B sin theta.
It will be equal to B sin theta. Rishi, is this clear?
Yes.
Okay. So you can write the formula for cross product, magnitude of cross product as A multiplied with B sin theta. This is only the magnitude part. You can also look at it the other way. You can consider it as B's magnitude taken as it is multiplied with component of A perpendicular to B. That if you visualize, okay. Let's first draw the direction perpendicular to B, this one. Okay. And with this direction, A will now be making 90 minus theta. And A's component in this direction, if you visualize, drop a projection from the head and the tail. This is the component of A perpendicular to B. Right? And that will be nothing but A sin theta. Therefore, you can write it as BA sin theta also. Anyway, these two are the same. Whether you take AB sin theta or BA sin theta, the result is going to be the same. But remember, cross product gives you the product of one vector and the component of second vector perpendicular to the first vector. Okay, so it's like, what can we say? In dot product, we multiply parallel components of vectors. In cross product, we multiply perpendicular components of vectors. So whenever this kind of an operation is needed, you will use cross product. In this chapter, you will understand where we'll need to multiply one vector and the perpendicular component of another vector. There we'll be using cross product. So that is how you understand whether dot product is to be used in a particular situation or cross product is to be used. It all depends on what kind of multiplication you need to do and what kind of result you expect, whether you want the result to be a scalar or a vector. Okay. So the magnitude of A cross B is AB sin theta. That is by definition. Now we need to assign a direction to this. Okay, we'll get to that, but let's consider the magnitude formula itself first. Magnitude of A cross B is AB sin theta. In this formula, what are A and B? What does A without a bar mean?
Third, the magnitude of
vector A. Now, magnitude of a vector can either be 0 or positive. It can never be negative. Similarly, B without a bar on it is the magnitude of vector B. That can also either be 0 or positive, never negative. And what is theta in this formula?
the angle between A and B.
Angle between the vectors A and B. That angle is what we call as theta. Fine. What is the possible range of angle between two vectors generally? Anyone? What is the possible range of angle between two vectors? Okay. Angle between two vectors will only be between 0 and 180 degrees. Okay. For example, if one vector is like this, one vector is like this angle may be around 37 degrees or something like that. Suppose one vector is like this, one vector is like this, 90 degrees. If one like this, more than 90, maybe 150 degrees or something like that. If they are opposite, it is 180. Okay. It cannot be anything more than that. So the maximum angle between two vectors is 180 degrees, minimum is 0. So it all depends on how they are oriented. So theta lies in the range 0 to 180. In the range 0 to 180, sine theta is either 0 or positive. It can never be negative. Okay. 0 to 90, sine increases. 90 to 180, sine decreases, but it's always positive. Sine 0 is 0, sine 180 is 0. Any angle between that, sine is positive. Therefore, the magnitude of cross product AB sine theta, if you use the formula this way as it is, this will either be 0 or positive. There is no chance of this term becoming negative at all. Okay. So we can use this for magnitude of cross product because magnitude can never be negative. Now you all tell me, suppose A is non-zero, B is also non-zero. Is there a chance that the cross product becomes 0? Magnitude of cross product becomes 0.
So yes, sir.
When?
If they are parallel.
If they are parallel. Okay. Theta is 0, then sine theta becomes 0. That means magnitude of the cross product becomes 0. That is one possibility. Any other possibility of AB sine theta becoming 0?
So 180 degree.
For 180 also, correct. Theta is 180 degrees, means vectors are opposite to each other. In that case also sine theta will be 0 and the magnitude of cross product will be 0. So what you need to remember is vectors which are parallel to each other or exactly opposite to each other, their cross product will be 0, irrespective of their magnitudes. Okay, so for 0 degrees and 180 degrees, the cross product is 0. For any other value in between, any other angle in between 0 and 180, you will get some magnitude of cross product definitely. Okay. When will the magnitude of a cross product be maximum? For which angle? Aishwarya, don't answer. Pawan or Rishi, you tell. For which angle will A cross B's magnitude be maximum?
Sir, when theta is 90 degrees, sir.
Okay, correct. Theta is 90 degrees. Then in that case, sine theta is 1. Then the magnitude of A cross B will be AB. Okay. This is the maximum possible magnitude of a cross product if A and B are fixed. Okay. So when two vectors are perpendicular, their magnitude, their cross product will be maximum, provided their magnitudes are constant. Okay. Fine. Next thing we need to discuss is the direction of cross product. This is slightly tricky and this is very important. Let's consider these two vectors itself. Okay, we don't even need all this. Fine. Let's say there's one vector A like this. Let's take it in green. Another vector B like this. Now it's not necessary that two vectors will always have their tails at the same position, but you can slide them and bring their tails together. Nothing wrong in that. Okay. So suppose there are two vectors like this and you want to determine the direction of their cross product. Fine. See, as I said, it makes no sense to multiply two quantities which have directions. Fine. There's no actual meaning of cross product. It's just an operation that we define because it will be useful in calculating some quantities. okay, in expressing some quantities. So direction is also assigned like that only. Depending on their use, they have defined it like this. Okay. Now, how did they define it? See, you consider any two vectors in space. Okay. If you join their tails together, they will form a V shape. They'll either be parallel, anti-parallel, or they'll form a V shape if you join two vectors. And a V shape can always be placed on a plane. Like in this example that you see on your screen, the vectors A and B, they are in the plane of your screen. Okay. You can try it with two pens. You take two pens, connect them at one end. Okay. You can always imagine a plane which consists both the pens. Okay. So two vectors are always coplanar. They can always be imagined to be on a single plane. Now, how did they define the direction of the cross product? They said that the direction of cross product, the direction of A cross B must be perpendicular to the plane consisting A and B. The vectors A and B. Okay. Like in this case, if you visualize vector A, vector B are in the plane of your screen, then what is the direction perpendicular to this plane? You have to imagine an arrow out of your screen, or you can imagine an arrow into your screen also. Okay. That will be the, I mean, that those two are the directions perpendicular to the plane consisting A and B. Now see, cross product cannot have two different directions. We should fix the direction. But I'm telling you, it will be one of these. Which one it is also we'll discuss. So if you're trying to find out the cross product of two vectors, first visualize the plane consisting those two vectors. Okay, plane is a flat surface. To any flat surface, you can imagine two mutually perpendicular, two directions which are perpendicular. For example, let's consider this mobile phone itself. You know, the screen is a flat surface. So you are looking at it from the side. You can imagine there are two vectors on the screen. Okay, so this screen is the plane consisting the vectors. Now, perpendicular to this plane, there will be two directions, one this way and the other one this way. Okay, so for any two vectors on the plane of the screen, the cross product should either be like this or it should be like this. Those are the only possible directions of cross product. Now, which of these exactly it is, we will discuss. Now, if the cross product is perpendicular to the plane consisting A and B, then automatically the cross product becomes perpendicular to vector A, and the cross product also becomes perpendicular to the vector B. Okay, so this is a very important property of cross product that you must keep in mind. When we take cross product between two vectors, the result is also vector. So that new vector, which is what we call as the cross product, will be perpendicular to these two vectors. Okay. Now, as we discussed, there are two possible directions perpendicular to both these vectors. Which of those two it is, you can find out using the right hand thumb rule. See, there are some other ways also, some other techniques also that people use, but this is the most common one, right hand thumb rule. Let's see how to apply this. Suppose you want the direction of A cross B. Okay, first case. If you want to know the direction of A cross B, A will be called the first vector and B will be called the second vector. To determine the direction of cross product, the order in which you are writing the vectors is very important. Okay, if you want the direction of A cross B, A will be called the first vector, B will be called the second vector. Now, how to get the direction of the cross product? You have to imagine something like this. Imagine moving along the direction of A and turning towards the direction shown by B. Okay. So basically, if you move in the direction of first vector and then turn in the direction of second vector, you will get a sense of rotation. Okay, or a sense of turning you will get. Then what you need to do is you have to curl your right hand fingers in that sense. Okay, that's the second step. And after that, extend your right hand thumb to get the direction of cross product. Okay, these are the steps to follow to determine the direction of cross product of two vectors. Fine. So you have to move along the direction of, instead of A, I think it's better if we write first vector. First vector. And turn towards the direction shown by second vector. If you do that, you will get a sense of rotation. Then you will have to rotate your right hand fingers that way, whether it is this sense or this sense, that you will have to first visualize and then rotate accordingly. Then the thumb will show you the exact direction of cross product. Let us try it in this case. Okay. You first have to move along the direction shown by the first vector. Direction shown by the first vector is this. So move this way. Then turn towards the direction indicated by the second vector. Second vector indicates this direction. So now you see there is a sense of rotation. There's a turning that you're taking. Okay. Now tell me, this sense as seen by you, is it clockwise or anti-clockwise? This sense of rotation.
Anti-clockwise.
Anti-clockwise. Okay. Now I want you all to do this. Take your right hand fingers and curl them like this. Okay. Use only right hand fingers, curl them this way, and then stick your thumb out. Which way is the thumb pointing?
Outside the screen, it's like
Okay. Okay. Pawan, what do you say? Which way is your thumb pointing?
Up.
Up means out of the screen. Aishwarya, are you also getting the same?
Yes, sir.
Okay. So see, we already discussed that perpendicular to the screen, there are two possible directions. It could either be like this, outwards, or it can be like this, inwards. Okay. To the screen on which you are seeing these vectors also, there are two possible perpendicular directions, outward and inward. Which of them exactly it is, you can confirm this way. So move along the first vector, turn towards the direction shown by the second vector, you will get a sense of rotation, and then either actually curl your right hand fingers or visualize curling your right hand fingers that way. You will get the thumb will show you the direction of their cross product. So in this case, the direction of A cross B is out of the screen. Okay, automatically that direction will be perpendicular to both vector A and vector B. Is it clear? Okay, now use these two vectors only, same vectors A and B. Tell me the direction of B cross A. For B cross A, B will be the first vector, A will be the second vector. The order is very important, as I said. Okay, so follow the procedure that I just told you. Moving along the first vector, turning in the direction of second vector.
they're inside the screen.
into the screen. We'll see. Pawan, what do you say?
Yes, sir.
Same. Aishwarya, what are you getting it as?
So the same.
Okay. So you should move in the direction of the first vector. This time the first vector is B, and then turn towards the direction pointed by the second vector. So you get a sense of turning, sense of rotation. This time the sense is clockwise. Now you curl your right hand fingers this way. Now to be able to curl your right hand fingers this way, you will have to place your right hand in such a way that the thumb points, sorry, not thumb, the palm faces in this direction. Only then you will be able to curl your right hand finger. See, there's only one way you can curl your fingers. You can't curl your fingers the other way. Okay. So if you want to curl your fingers along the this yellow curve, you will have to place it in such a way that the thumb points into your screen. Okay. Therefore, if you extend your thumb, it's into the screen. That is the direction of B cross A. So what we observe here is that A cross B and B cross A have exact opposite directions. Their magnitudes are the same. Whether you write AB sine theta or BA sine theta, the magnitude is the same. But direction wise, they are exactly opposite. This is something very important. You should never change the order of vectors in a cross product. In dot product, you can change. A dot B is AB cos theta. B dot A is BA cos theta, which is the same thing. Dot product doesn't have direction. Okay. But for cross product, the order is very important. So you can say that A cross B has the same magnitude as B cross A, but directions are opposite. Therefore, A cross B is negative of B cross A. When are two vectors said to be negatives of each other? When their magnitudes are same, but directions are exactly opposite. Okay, so for cross product, whenever cross product is being taken, the order is very important. Fine. So did you all understand how to determine the direction of cross product? You first have to visualize moving in the direction of first vector, turning in the direction shown by the second vector. Then based on that sense of rotation, you can easily tell. Okay. Let's quickly solve some problems. I want you to find out the magnitude of cross product and also the direction in all these cases. Okay, I'll just give you 3 examples. And be very careful while solving problems. Don't be in a hurry to answer. Suppose these are the vectors. First vector magnitude let it be 10. This vector's magnitude let it be, okay, I have to name them. This angle is given 53 degrees. Okay, fine. Determine magnitude and direction of their cross product. You can type your answers in chat. Just type the magnitude and then the direction, inwards or outwards. In all cases, I want A cross B only. So tell me, I just wanted to ask you this. What is the angle between vectors A and B in the first case? Angle between vectors A and B.
Sir, it's not 53, I just realized. Because the tail and the head are matching. It should be head, tail and tail.
Huh. The angle between them is not 53. So that's where you need to be careful. But in case of cross product, it won't hurt you much because, see, let me copy these two vectors. To get the magnitude of cross product, we need to take AB sine theta, where theta is the angle between the two vectors. Now, the correct angle, the proper angle between these two vectors is not 53 degrees. To visualize angle between two vectors, you have to imagine their tails at the same point. It's actually 180 degrees minus 53 degrees. That's the actual angle between these two vectors. And if you want the magnitude of their cross product, you are supposed to take AB sine of this angle. So this becomes 10 into 20 into sine 180 minus 53. Okay. But luckily, or fortunately, sine 180 minus theta is same as sine theta. So this is the same as 10 into 20 into sine 53. So even if you had taken 53 degrees and calculated, you would have gotten the same answer for cross product. But remember, in dot product, this will hurt you because cos theta is not same as cos 180 minus theta. There a negative sign will appear. Okay. For cross product, it won't make any difference. Okay. So your answers are most likely correct only. Anyway, so 10 into 20, 200, sine 53 is 4 by 5, 200 into 4 by 5, 160. Magnitude of cross product in the first case is 160. And direction. Move in the direction of first vector and turn to the direction shown by the second vector. Clockwise rotation indicates into the screen. Okay, into the screen is indicated by a cross in a circle. Fine. Next case, it's straightforward. The angle 120 is actually the angle between the two vectors. You can use it off directly. So 10 into 10, 100 into sine 120. Sine 120 is root 3 by 2. So it becomes 50 root 3. And we need A cross B. So move in the direction of A and turn towards the direction pointed by B. Again, clockwise rotation. So into the screen. Third case also, the tails are together. So 150 degrees is the actual angle between the two vectors. And AB sine theta, if you take 10 into 20 is 200. Sine 150 is same as sine 30, which is 1 by 2. 200 into 1 by 2 is 100. Next is direction. Move in the direction of A, then turn towards the direction shown by B. Anti-clockwise sense of rotation. Curl your right hand fingers anti-clockwise. You will see the thumb pointing outwards. So out of your screen. And out of your screen is indicated, out of the page or out of the screen is indicated with a dot placed inside a circle. Fine. All of you have given the same answers, correct. Good. So if two vectors and the angle between them is known, I mean, if magnitude of two vectors and the angle between them is known, this is how you find out their cross product. Okay. But many times, you know that vectors are given in their component form. Okay, in terms of I cap, J cap, and K cap. So we should know how to express cross product in those terms also. Now, okay, this is the x-axis. This is y-axis. Remember, in the Cartesian coordinate system, which is what we follow, okay, if x is taken to the right and y is taken upward, then positive z-axis must be out of the screen. Into the screen cannot be called positive z. It must be called negative z. Out of the screen is positive. Okay, so this is the positive z direction. I'm assuming this is outward. Okay, out of the screen. It is compulsory that it has to be like this. Okay, fine. Now I cap is a unit vector in the positive x direction. Its magnitude is 1, its direction is this way. J cap is a unit vector in the positive y direction. Its magnitude is also 1 only. And its direction is this way. And K cap is a unit vector in the positive z direction. This way. And x, y, z are mutually perpendicular directions, means the angle between any two of these vectors is 90 degrees. Fine. Now, tell me, what will I cap cross I cap be? You just treat it as A cross B. Assign a magnitude, assign a direction. how much will the magnitude of I cap cross I cap become?
0, sir.
Why?
The angle between them is 0.
Because the angle between them is 0. Okay, not just I cap cross I cap, any vector cross itself, the cross product is 0 because the angle is 0. So their actual magnitudes are 1 and 1, A, B, but angle between them is 0. So the answer is a null vector. Okay, properly saying it's a null vector. Similarly, J cross J, K cross K also. Fine. Next, I cap cross J cap. I cap magnitude is 1, J cap magnitude is 1. I and J are perpendicular vectors, so the angle between them is 90. All this is fine. Now assign a direction to it. Rishi, you tell me what will be the direction of I cap cross J cap?
Sir, outside the screen.
Out of the screen. And in this case, out of the screen is the positive Z direction. And positive Z direction is indicated by the vector K cap. Sin 90 is 1, so the first bracket becomes 1. Therefore, I cap cross J cap is K cap. Okay. Next, J cap cross K cap. Visualize this carefully. You'll have to curl, or you'll have to move in the direction of J and then turn towards the direction of K. Means you have to turn out of your screen. Okay, first move upward, then move towards yourself. Okay, and curl your right hand fingers that way. In which direction will the thumb point? Pawan, tell me what is the direction of J cap cross K cap?
Right.
I cap. Okay. J cap means you'll have to imagine moving up first. Then K cap is towards you. You'll have to imagine moving towards you. If you move up and then towards you, you will have to curl your right hand fingers this way. Okay. So the thumb will point to your right. Okay. This is right for me. So, and right is indicated by I cap. So J cap cross K cap, the magnitude will be 1. Direction is positive X, and positive X direction is denoted by I cap. Okay. Similarly, K cap cross I cap, if you visualize, it will be J cap. Fine. So Ij gives K, Jk gives I, Ki gives J. Fine. Now suppose you are given two vectors like this. One vector having an X and Y component. Another vector also having an X and Y component. And you need to take their cross product. Okay, all you have to do is write the vectors as it is first. And then, like in mathematics, how would you multiply A plus B into C plus D? You will do AC plus AD plus BC plus BD. Same thing you will have to do here also, but you will have to take cross product. So what you need to do is AX I cap cross BX I cap. First term. Next, AX I cap cross BY J cap. Next, AY I cap cross BX I cap, sorry, AY J cap cross BX I cap plus AY J cap cross BY J cap. So basically you'll have to take cross product of every term of the first vector with every term of the second vector. If there are three components also, you'll have to do it like this only. Two components like X and Y components, 2 into 2, you'll get 4 terms. If there are three components, you'll get 9 terms. But some of those terms will be 0, so it won't be that complicated to express the final answer. Okay, we'll come to 3-component multiplication in a while. Let's try this first. Suppose you are given 2 vectors like this. Okay. Do this quickly and tell me A cross B in all these cases. Suppose this is vector A and this is vector B. How much is A cross B? Type your answers in chat. Let's see. As I said, you have to take cross product of each term of the first vector with each term of the second vector. Okay. So first, 2 I cap cross I cap. How much will that be? Two I cap and I cap are in the same direction. Their cross product will be 0. Okay, or a null vector. Next, 2 I cap cross 2 J cap. 2 2s is 4 and I cross J is K. Second part, 3 J cap cross I cap. 3 into 1 is 3. How much is J cross I?
Minus K.
I cross J is K, then J cross I will be the negative of that, minus K. Minus K cap. And finally 3 J cap cross 2 J cap. They are in the same direction. Their cross product will be a null vector. So the answer is 1 K cap. Or you can simply write it as K cap. Pawan and Rishi, is this clear?
Yes, sir.
Yes, sir.
Okay. Try this now. Okay, I'll give you the vectors directly. Again, just take cross product of each term of the first vector with each term of the second vector carefully. So first these two, then the next two and so on. Okay. Make it fast. Okay, Pawan, tell me, what is minus 2 I cap cross 2 K cap?
Sir, minus 4 J cap.
Let's see. Minus 2 and 2 is minus 4. And then I cross K. K cross I is J. I cross K will be minus J. So minus 4 and minus J. See, the order is very important. As I said, K cross I is not same as I cross K. Okay. So here, this is the first vector and this is the second vector. You cannot interchange them. Pawan, is this clear?
Yes, sir.
Okay. Rishi, you tell me now. What is minus 2 I cap cross minus I cap?
Sir, it'll be 0 only because
0.
I and
0. Correct. Then next two. 4 J cap cross 2 K cap. Aishwarya, how much is this?
8 I cap, sir.
4 2s is 8. J cross K is I. Okay. So 8 I cap. And then the last two. 4 J cap cross minus I cap. Pawan, how much will this be?
Sir, plus 4 K cap.
Okay, let's see. 4 and minus 1 is minus 4. Then J cross I is minus K. Okay, so plus 4 K cap, correct. So the answer is 8 I cap plus 4 J cap plus 4 K cap. Okay. Now see here, this was the first vector and this was the second vector and this is their cross product. Now in the beginning we discussed that the way it is defined, the cross product is perpendicular to both the given vectors. Let us check that. Can any of you tell me a way to check if two vectors are perpendicular or not? A standard mathematical procedure to check if two vectors are perpendicular. If two
So the cross product should be 0.
why will cross product be 0 for perpendicular vectors? Dot product should be 0.
Sorry, dot product.
Let's try that. Let's take A dot A cross B and check if it is 0 or not. A vector is minus 2 I cap plus 4 J cap. You have to take its dot product with 8 I cap plus 4 J cap plus 4 K cap. Rishi, tell me, how do you take dot product when vectors are given in component form? Anyone? You just write AX BX plus AY BY plus AZ BZ. You just have to multiply their scalar components, corresponding scalar components separately and add them. No direction, no I cap, J cap, K cap will be written. So here AX is minus 2, BX is 8. That's the first term. AY is 4, BY is also 4. That's the second term. A doesn't have a Z component, B has a Z component, but it doesn't matter anyway. So minus 16 plus 16, the answer is 0. And as expected, the dot product has turned out to be 0 because the vectors are perpendicular, like proving that the vectors are perpendicular. So the cross product A cross B is definitely perpendicular to A. It will also be perpendicular to B. You can check if you want. Okay. See, there is another method also to determine or to express the cross product, the determinant method. Okay. They write it like this: I cap, J cap, K cap. Then write the components of the vectors: AX, AY, AZ, BX, BY, BZ. You evaluate this determinant, you will get the cross product. Okay. But that much is not necessary. I'm not going to teach you determinant of a 3x3 matrix. If you know, you can apply it. Otherwise, just multiply them term by term like this, you will get. And as far as physics at your level is concerned, you will only have vectors with 2 components. Even if you have 3 components, this procedure will work. Okay. Every component of first vector, take cross product with every component of the second vector. You can write off the cross product. Okay. Fine. So yeah, that is all you need to know about calculating cross product of 2 vectors. Remember the meaning first. The cross product of 2 vectors helps you multiply one vector as it is and the second vector's component perpendicular to the first vector. So like in this chapter itself, we'll come across some quantities where we'll need to do that kind of multiplication. Okay. In those cases, you will use cross product. And also remember, cross product is a vector quantity. Okay, we know how we discussed how to write the magnitude, we discussed how to find out the direction. Then even in case of vectors written in analytical form, I cap, J cap and K cap, we have discussed how to evaluate the cross product. That's enough. So you can write A cross B as the magnitude AB sine theta, and it should have a direction, no? That direction, they indicate it as n cap. How to find out n cap direction is the right hand thumb rule that we have discussed. So this is how we express the cross product. This is a magnitude, this indicates a direction. That direction could be I cap, J cap, K cap, it could be something else also as shown by the right hand thumb rule. And when is cross product 0? When vectors are in the same direction or exactly opposite. Okay, for parallel vectors and anti-parallel vectors, the cross product is 0. And when the vectors are perpendicular to each other, you get the best possible value of cross product, highest possible value of cross product for vectors of given magnitudes. Okay, fine. So in rotational mechanics, we'll be coming across quantities like angular momentum and torque. Okay, which are the next things that we are going to discuss. So in those calculations, we will need cross product. Okay, fine. Thank you all. We'll continue in regular classes.
Thank you, sir.